Hello everyone, and I hope all is well. Today we will talking about the formation evaluation in day 2. Just remember what we learned in day 1. We are talking about the formation evaluation data and sources, starting from the mud logging. The mud logging depends on the cutting and drilling parameters. Also the coring depends on the drilled core and sidewall core. Also the open hole logs after or while drilling operation, and cased hole logging during or after production operation or production life cycle of the well. The last formation evaluation data and sources is the borehole seismic. So in yesterday, we are talking about the integration between the formation evaluation data, starting from the static model, borehole seismic, mud logging data, coring data, also the open hole logs data. And the second phase is the dynamic model, starting from the cased hole logging and the field performance or field studies. In day 1, we are talking about the mud logging. Mud logging is considered as the first information during the drilling. Mud weight, rotary speed, wet in bit, cutting analysis, gas content, pH value, mud salinity. And this picture considering the mud logging example regarding all the drilling parameters data. Also, in day 1, we are talking about the cores. The cores allow the direct measurement of reservoir properties and also used to correlate indirect measurements such as wireline LWD logs. And this is the information from cores. We have two types, standard analysis and special core analysis. Also, we are talking about the well logging process and the well logging classified into two types, open hole logs and the cased hole logs. And in day 1, we are talking about the wireline logging acquisition system or wireline unit, and which components of the wireline logging acquisition system. Also, we are talking about the wireline tool conveyance, starting from the tractor, electric wireline cable, stick line or digital stick line, drill pipe, production tubing, coiled tubing, and logging while drilling or LWD. And also we are talking about the basic open hole logging tools. In day 1, we are talking about the lithology tools, spontaneous potential SP and gamma ray. And also we are talking about the fluid identification tools as a resistivity log. And today we are talking about and covering the petrophysical tools for porosity measurement, such as neutron density sonic log. And in day 1, we are talking about the auxiliary tool as a caliber log for borehole geometry. And also we are talking about the calculation for cement volume using the caliber log. This picture considering an example for gamma ray log. When we are talking about the gamma ray, we are talking about the shell formation, the hydrocarbon formation. Also, we are talking about caliber log example as just the borehole diameter and the condition for the borehole. Also, we are talking about the spontaneous potential log response as it's will define the permeable layer and non-permeable layer or impermeable layer, and will define what about the hydrocarbon zone or reservoir bed as it's using the spontaneous potential data response for this. Also, we are talking about the resistivity log. When we are talking about the high resistivity, we are talking about hydrocarbon. And you are talking about two types of resistivity, lateral log and induction log. Today, we will start from the porosity logs. we have three main types of log in porosity determination, starting from the bulk density log, and the second one is the compensated neutron log, and the last one is the sonic log. Sometimes the commercial vendors have commercial names like CMR, like density log, but the main types of porosity logs is the three types. When we are talking about the density logs uses a radioactive source to generate gamma rays, and gamma ray collides with electrons in formation and losing energy. So the detector measures reduce the intensity of gamma rays. The density log measuring the number of gamma rays and their energy levels at a given density from the source. And the detection density or the electron density of the formation can be predicted. And as you see in this picture, the density is inverse proportional with the porosity, as the porosity is very important for reservoir formation and bay zone, and you will consider the density in this log, and just you can convert this to be a porosity measurement. But what about the formation itself? To use a source for gamma ray or a source for this log, you have to put two detectors into a different spacing interval, starting from short spacing detector, and the last one is the long spacing detector. The density log affected by the mud cake and affected by the condition for the wellbore. This is an example for bulk density log, considering the response taken from this log. If you have a bay zone in any interval, you will get an indication and response in density log, and we will consider it in the interpretation process. So the response of density tools is a function of the formation electron density. So the electron density is a measure of bulk density. Bulk density is dependent upon the rock lithology, the formation porosity, and also the density and saturation of fluid in pore space. This is the equation for the bulk density using the metric density, also using the porosity, and using the fluids in flushed zone and the porosity for flushed zone formation or flushed zone area. When we are talking about the porosity from density log, the porosity equation using this formula or this equation to detect or to measure or to calculate for porosity calculation using the matrix density and bulk density and also fluid density or formation fluid density. The formation or the fluid density equation considering the mud filtrate density rho mf and also the saturation in the flushed zone, also considering the rho for the bay zone and for the mud filtrate. This is the working equation for bulk density, and this is very important to know that the equation is very important for the logging interpretation, and we are talking later on the interpretation process. Now we are talking about the factors affecting density log response. What is the factors affecting the density log response? One of the great factor here is the borehole and the mud filtrate effects. density for mud filtrate can be measured, and also the saturation for the flushed zone or for the mud filtrate can be calculated from shallow resistivity logging tool. As you know that we have two detectors in shallow interval length and in long interval length. The second factors affecting density log response is the shales and the clays. The shale volume and the density for shale can be obtained from log reading in shale zones. And the hydrocarbons type will affect on density log response. As in oil zones, the rho for hydrocarbon equals the rho for oil, which can be measured from fluid samples. And in gas zones, the rho for hydrocarbon is equal the rho for gas, which can be measured or calculated using gas properties and correlations. So when we are talking about the bulk density log example, you have to put the type of formation, you have to put the borehole condition, you have to put the hydrocarbon type in your consideration when you are dealing with the bulk density log data. The density or phi, d phi, calculated and processed from the log will consider all the factors affecting the bulk density. The second porosity or the second main type of porosity log is the neutron log. The logging tool emits high energy neutron into formation, and these neutrons collide with nuclei of formations atom, and these neutrons lose energy or velocity with each collision. So the hydrogen is the most effective element in the showing down elastic scattering process of the neutron, and it's all type of hydrocarbon have the hydrogen in most type of your wells. So the neutron log, the most energy lost when colliding with a hydrogen atom nucleus, and neutrons are slowed sufficiently to be captured by nuclei, and this capturing nuclei become excited and emits gamma rays. So depending on type of logging tool, either gamma rays or neutrons emitted or are captured, and the log records porosity based on neutrons captured by formation. And if the hydrogen is in poor space, porosity is related to the ratio of neutrons emitted to those counted. And this is the theoretical equation for the porosity coming from the neutron log depends on some factors like the porosity for the mud filtrate, the saturation for flushed zone and mud filtrate, and also depends on the shale volume. It's a theoretical equation, not a practical equation in all type of formation. And when we are talking about porosity coming from the neutron log, we are talking about the neutron log response. As you see that the neutron log response may be or could be different from a different response from the density log response. So what is the factors affecting porosity tool log response? We have three factors in this case in neutron log: the porosity of formation, the lithology of formation, and the fluid content. This is an example for compensated neutron log to expect or to estimate and calculate the porosity for reservoir and non-reservoir zones. The third type, or the third common type of porosity log, is the sonic log. The sonic tools are based on the measurement of the velocity and amplitudes of the sonic body waves in the rocks. And it has a great application in our industry, as it can evaluate and detect the mechanical properties such as rock strength, earth stress, rock and mechanical properties, and rock failure mechanisms. And also it have a great application and a wide application in the formation evaluation and cement bond logging. So the acoustic impedance or acoustic sonic log tool usually consists of one sound transmitter above and two receivers below. The sound is generated and travels through the formation, and the elapsed time between sound wave at the first receiver versus the second receiver is dependent upon the density of medium through which the sound traveled. And as you see here, you have a lower transmitter and you have upper transmitter, and in between you have multi receivers for receiving the sonic wave and calculate or estimate the time. The delta T in this working equation will consider all the factors affecting on the sonic log response, and will consider what type of fluid, hydrocarbon or non-hydrocarbon, and the sonic travel time will used or utilized to calculate what about the sonic porosity. So the sonic log response can be written as follows, as T log or time from log depends on the matrix time and the fluid time, and will detect or calculate the porosity from sonic log using this equation. This equation using the time for log and the matrix time and time fluid. When you are dealing with this equation is similar to the concept for density log or porosity from density log. The guideline as if you are dealing with oil and if you are dealing with gas, you have a different reading and different response in delta T from the sonic log response. So what about the common lithology matrix travel times used? When we are talking about the lithology such as sandstone, limestone, dolomite, anhydrite, salt, you have a typical matrix travel time will be used and utilized in the previous equation, and to detect the porosity coming from the sonic log. Now the question is, what is the factors affecting the sonic log response? The factors affecting the sonic log response is the unconsolidated formation, or sometimes we are talking about the compaction correction factor, about 1.6 for unconsolidated sand. And the second factor is the naturally fractured formations. And the third type is the hydrocarbons type, especially in gas zone or in gas formation zone. And the ruggous salt section, if you have a massive salt section, or if you have a salt bed in your or salt section in your reservoir, or in your logging interval. The responses of porosity logs, as the 3 porosity logs respond differently to different matrix compositions, and this respond differently to presence of gas or light oils, and you have to combine between all type of logs to give you the correct answer about the type of hydrocarbon in pore space. So the most common effect of hydrocarbon is the gas effect. When we are dealing with density log or density porosity log, the gas effect make or effect on density from density log response is too high in gas zone, and the neutron response is too low. But in sonic log, the response is not significantly affected by gas, not affected by gas in sonic log. So the cross-plot porosity guideline will consider this in the equation for cross-plot. So when you are dealing with gas, you are dealing with a square root equation, and when you are dealing with the oil zone, you are dealing with a straight equation or direct equation. This example, considering the gas effect coming from the porosity and coming from the density and sonic log and neutron log. In this example, we are dealing with interval from 10,720 to the interval of 10,730 feet. In this area, we are dealing with a separation between the two types of log, density and neutron log, and this separation in the front of a hydrocarbon zone or a gas bearing zone. So the gamma ray here is very clear to have a section for a reservoir, and the resistivity is good or high in this response, and the separation between the density and neutron log is wide, so that you will define this interval as a gas formation or a gas zone. One of the important parameter when we are dealing with formation evaluation is the water resistivity. When we are dealing with any equation or any calculation or any logs, you have to identify what about the water resistivity. To determine the water resistivity, you have 3 methods. The first one is the direct method from measured water sample, from actual measured water sample analysis. And the second one is the indirect method from open hole well logs, such as spontaneous potential, Beckett plots, the RWA technique. And the third one is the empirical equations. And you have 2 types of equation in RW or water resistivity calculation for consolidated and unconsolidated formation. You have 2 types of equation or empirical equation. One of the tool we are using information evaluation is the porosity crossplots. What about porosity crossplots? Porosity crossplots can be used when 2 porosity logging tools have been run if one of tools was neutral log. At any times, the cross plot considering neutron log is a basic tool, and you have to consider what about the other tools. If you dealing with density neutron cross plot, the second type is to deal with neutron sonic or sonic neutron log. So the formations of two known lithologies can determine a more accurate value of porosity, and also can determine the percentage of each mineral using the cross plot lithologies. You utilized it to consider what about the accurate value, of porosity, and what about the percentage of mineral makeup. So the common porosity cross plots is neutron density or sonic neutron. When we are dealing with neutron density cross plots, you have to deal with the clean liquid saturated formation, and also you have to deal with the boreholes filled with water or water-based mud. This is the application for neutron density cross plot. This figure will consider the neutron porosity index and the bulk density reading, and the density porosity coming from this cross plot. You will consider this chart for a certain value for density of fluid. As you see that in red color value, you deal with a density for fluid is equal 1. This is a freshwater density. And in this case, you are dealing with a different fluid density as equal 1.1. And you can use the published charts for the neutron density cross plot, and also you can consider another type of cross plots as sonic neutron cross plots. Sonic neutron cross plots developed for clean liquid saturated formations, and also boreholes filled with water or water-based mud. This one of the types of neutron porosity coming from neutron sonic cross plot regarding the formation type and regarding also the sonic transit time value in microsecond per feet. But generally, when you are dealing with the interpretation process, you have to know the equation for formation water resistivity calculation. This is a very important equation, and this equation is called Archie equation. This equation to detect and calculate the water saturation using some constant factors, and also using the water resistivity or resistivity of formation water in ohm meter, and also the resistivity of uninvaded formation in ohm meter unit, and using the porosity and using the sedimentation exponent usually near 2, and also using the empirical constant usually near unity, and also using the saturation exponent also usually near to be 2. This table will illustrate a summary for the most common type of open hole logs, starting from the gamma ray tool. The gamma ray tool measures the natural radioactivity, so it's have no source here, and applicable for reservoir detection. The second tool, or the second common tool, is the density tool. The density tool use a gamma ray source and measure the electron density, and applicable in porosity determination, reservoir detection, lithology identification, and hydrocarbon type identification. The third type of open hole log tools is neutron. Neutron using a neutron's source and measure the hydrogen index of hydrogen per unit volume, number of hydrogen per unit volume, as it's the hydrogen index, and the application of neutron log in porosity determination, reservoir detection, also in lithology identification, and hydrocarbon types. The fourth type of open hole tool of open hole logging tools is a sonic log. Sonic log using a sound source or a sonic wave source, and measures the transit time from transmitter to receiver, and the sonic log applicable for porosity calculation and seismic calibration. Also applicable in the encased hole logging for cement evaluation log. The last tool in open hole logs, and it's very common and wide range, is the resistivity tool. Resistivity tool using a current source and measures the voltage value, and applicable in saturation calculation and to identify the type of fluid. And also resistivity tool nowadays can measure an open hole and encased hole with a different tool configuration and different specification, but with the same theory of the resistivity tool measurement. And this chart will give you an example or an identical value for the depth of investigation of every tools. For every tools, resistivity tool as induction log have a great depth of investigation, and the lateral log have a medium depth of investigation. And if you are dealing with the neutron, the gamma ray, the density log, you have to deal with the maximum depth of investigation or the identical depth of investigation. And also when you are dealing with the sonic, you have a limited value for the depth of investigation. And if you are dealing with the resistivity tool, you will consider the micro resistivity, the micro log, and also the deep meter log. The deep meter log using to identify and measure the dip angle of the formation. As you know that the dip angle of the formation is very important in reservoir identification and information evaluation, as also the dip angle to be considered in the directional drilling calculation, and also to be considered in the reservoir studies and field development plan. So when we are talking about the measuring in the borehole, the formation to be measured is masked by the borehole, and the borehole contains fluids and is of an irregular shape. This fluid may be drilling fluid, completion fluid, hydrocarbon fluid, and so on. The borehole fluid can be water-based mud, fresh or salted saturated mud, and also can be oil-based mud with varying quantities of water, and also can be air and also can be foam. The sensor has to be able to measure the formation property accurately and send the information to surface. So the borehole fluid identification is very important in your tool configuration and also in the calibration for tool and surface. This is one of the important method and one of the important rule in tool calibration and tool configuration in your system. And also the main factor here is the tool positioning. As you know that the depth of investigation for many types of tools is not the same value. So the tool positioning is very important. So we have three types or three configuration for tool positioning. The first one, as the some tools are run centralized in the borehole in order to measure in proper way, and this include lateral log and sonic devices. So you will utilize or using a centralizing tool or a centralizer for this case. The second configuration for or position for tool, as some tools are run eccentric or in eccentric position, pushed against the borehole wall. In some cases, this is done with an eccentrizer. In other cases, a caliper arm does this job. The caliper will drag or swell in one side, and the tool will position in the another side. This technique utilized in open hole and nowadays in cased hole. Sometimes you have to stress or focus in perforation interval in cased hole in one type or one side of your reservoir to get the productivity as you need in this case. This tool and perforation is a oriented perforation tool. It's the same idea here, but here using a caliper to drag, caliper arm to drag or to inflate in one side, and the other side is the tool position. But in a cased hole, the oriented perforation tool will guide the perforation gun in one side or one direction or one phasing to get the most or efficient productivity from the formation. The third tool position, as some tools are run with a standoff to position them at a fixed distance from the wall, like induction families, as the induction tool depends on the spacing or the distance from the formation, and also this will affect the depth of investigation and the reading for the induction family tools. When we are talking about the quick log interpretation or early interpretation, when we are talking about the early resistivity logs we're used to find the possible reducing zones, when you are dealing with resistivity log, if you will give or got a high resistivity equal hydrocarbon. When you are dealing with spontaneous potential log, the spontaneous potential was used to define what about the permeable beds and compute the water resistivity, formation water resistivity, and determine the shellness volume. Also, the resistivity was used to determine porosity, as the RC equation developed the relationship between resistivity, porosity, and water saturation. The interpretation process coming from the lithology identification, the porosity logs, density, neutron, sonic log, also the cross plots using two types of cross plot. The first type is density neutron. The second type is the sonic neutron. And also the interpretation process will detect the water saturation, and sometimes you have to get or inform the all people what about the quick log interpretation process. In this case, the operating company or the exploration company have to gather all data coming from the core data, the geological data, the regional data, also the 2D or 3D surface seismic, and also the borehole seismic, the open and cased hole logs, and also the information from the nearest well or the offset well or nearby wells. All of this data will form an integrated formation, an integrated information about the formation evaluation, and you will consider all disciplines and all engineers and all people here in this great network. But the question is, what is the steps for quick log interpretation or quick log evaluation? When we are starting the quick log evaluation, we starting from the rocks. The first step to define or to identify the type of rock, reservoir rock or non-reservoir rock. When you are reach to define the reservoir rock, you have to identify what about the hydrocarbon bearing zone and what about the water bearing zone. And when you are reach to hydrocarbon bearing zone, you have to identify what about the gas bearing zone and evaluate it, and what about the oil bearing zone to be evaluated. To be evaluated in 4 steps: to locate the reservoir, and the second steps to detect the hydrocarbon type, and to distinguish between oil and gas and differentiate between oil and gas, and the 4th step to evaluate and compute the porosity, the formation water resistivity, and the hydrocarbon saturation. So when we are dealing with the quick log evaluation, we will match it, or we will go to this 4 steps to be able to evaluate the formation and to compute all parameters we need in formation evaluation process. This is an actual log regarding the gamma ray log, the neutron density, neutron in blue color and density in red color, and also the resistivity in ohm meter in this area of log. When we are dealing with this log, the first step to identify the reservoir interval. As the gamma ray is low here, this is a reservoir zone. The second one, to identify what about the hydrocarbon zones, you have to deal with the resistivity log. If you have a high resistivity, you have a hydrocarbon. And to differentiate and to distinguish between oil and gas, you have to deal with the density neutron log. If you have a great separation and a gap between the neutron and the density log, you will get a gas here in this area. And the 4th step to evaluate what about the gas zone, and what about the oil zone, and what about the water zone. And the last step here to calculate all parameters like the formation water resistivity, this is from water zone, and also to calculate what about the water saturation. The water saturation will be calculated using the value of water resistivity from the Archie equation and using the parameters coming from the open hole logs. So you will use the equation for porosity from the density log, and this is an example to be utilized in this calculation, and different values for rock matrix like sandstone, limestone, dolomite, and also the borehole fluid, starting from fresh water, salt water, fresh water with 30% residual oil, and also fresh water with 30% residual gas, and the other mineral like halite and anhydrite. When we are dealing with the density log equation, you are dealing with the porosity from density, and you have to determine what about the water resistivity from this equation, and determine what about the water saturation. So this is an example of evaluation log, starting from when you are dealing with the resistivity log, the gamma ray log, you will identify and will compare between the reservoir and the non-reservoir. So you will give a line and draw a line for the low value of gamma ray, and in the last side, in the other side, you will draw a line in the high gamma ray value, the high gamma ray value for shale and the low gamma ray for sand. And you have to draw a straight line in the middle value or the average value for the gamma ray log. This is the very first step to identify what about the reservoir formation and what about the non-reservoir formation. So if you see here, you deal with this as a high gamma ray value. This high gamma ray value regarding the shale. The shale is non-reservoir. If it not contain oil or gas, it's a non-reservoir formation. And the formation with low gamma ray, it's a reservoir section. The second step, to stress or focus in oil zone and also in water zone. And you need to know what about the resistivity here. Resistivity, high resistivity in reservoir zone will give you answer about the hydrocarbon interval or hydrocarbon zone, oil or gas. And if you need to differentiate between oil and gas, you have to consider what about the value and response for density neutral log or sonic neutral log. And if you have to deal with the water zone have a low gamma ray as it's a reservoir section zone, but the resistivity here will be low, and the porosity here and response for the porosity logs will affected by this value. See, so if you are dealing with this value, you are dealing with the oil zone here and the water zone here as the resistivity and porosity logs affected by the water fluid zone. This calculation is very important, and this is a summary for quick log evaluation for open hole logs, starting from the first step to identify the reservoir interval, the second step to identify the hydrocarbon zones, the third step to differentiate between oil and gas, and the last one, and the last step to evaluate what about water, oil, and gas zone, and compute all parameters and all factors like water saturation, and first you have to compute the value for water resistivity, and finally you have to write a report for each major reservoir and fluid type report. This report will contain the total net thickness or the net base thickness and the average porosity and the average hydrocarbon saturation. And this report also will contain the parameters used like this is water resistivity, M and N exponent, and the fluid contact levels. As you know that you have to define what about the oil water contact and what about the gas oil contact if you have a gas, oil, water zones in your reservoir. And one of the main properties coming from logs and will be have a great benefits in our production operations and the stimulation operation is the mechanical properties from logs. We are using the sonic data to detect and measure the mechanical properties of the rock and can be calculated to given a continuous stress and the mechanical properties profile, but it very needs to be calibrated with external data, either from core test or data frac or mini frac analysis. So one of the major type of log is the FMI or fracture identification tool. This tool needs to describe the type and the distribution of porosity in a carbonate section, showing 3% porosity on conventional logs. And the FMI indicates abundant fractures and also indicates this well was perforated from interval of depths, and the end interval or the bottom interval will last and will consider the water or oil fluid coming from the formation. After we summarize the open hole logging and its interpretation process, now we are talking about the formation, pressure, and fluid sampling. If you are dealing with any oil or gas or reservoir zone, you have to measure and record the formation pressure. And at many times, you have to collect a fluid sample for analysis and for more data information about the base zone and about your produced fluid in the future. So the question is, what about the objective of the well formation testing? The first one is to determine the reservoir pressure and also to confirm what about the fluid type that evaluated from the other logs or the other open hole logs, and also to calculate the oil, gas, water densities at reservoir condition, as you sometimes you have to get a sample from your reservoir, and also to differentiate and determine and identify the contacts, the fluid contacts, starting from free water level, gas oil contact, and the gas water contact, and sometimes the oil water contact. And also one of the main objectives for formation testing and the reservoir pressure evaluation is to identify what about or determine what about the reservoir permeability and mobility. This is a very important application or benefits coming from the formation testing and formation sampling. The history of wireline testing tools, we have an old-fashioned tools coming in the years of 1955 to 1975. This tool is a formation tester. This is a simple tool, but the recent from this coming from year of 1975 to till present is a repeat formation tester or RFT. And the advanced and recent tool is MDT or modular dynamic tester or modular formation dynamic tester tool. This tool have a great benefits, also have a great specification and accessories regarding the fluid analyzer, regarding the dual probes, regarding the types of samples, the number of samples, also regarding the pump out option and the power telemetry system from electric power and the hydraulic power telemetry system, and sometimes have a dual backer option. This option have a great effect in very tight formation, especially in tight gas zone or tight oil formation. To consider that the dual backer will focus a very short interval of reservoir and to consider the tightness effect of the oil or gas bearing zone. When we are talking about the MDT, modular dynamic tester tool, this is a basic configuration tool containing a probe module to have access to formation fluids and the pressure like injectors, and also containing a sample chambers to collect the formation fluid sample, and also have an electrical and the hydraulic power module to operate the tool in the downhole position and to give you an answer in surface readout data. And you can calibrate and fine-tuning the configuration and the response from tool at any time. The configuration of a modern wireline tester have a standard tool modules, electrical power, hydraulic power, single probe, and sample chambers. And sometimes you have to add an optional tool modules like dual probe, flow control valve, dual backer in case of you have a tight zone or a tight formation, and multi-sample modules for get a downhole sample and downhole sample in single phase, and also in the actual phase in the reservoir, and also the pump out module if you have to get more samples, and sometimes you have to release and dump your sample in the borehole, and also the fluid analyzer. This fluid analyzer will give you answering about the fluid analysis in downhole condition, and no need to get the sample to the surface and send it to lab, but the optical fluid analyzer will get you and give you a complete analysis regarding the optical fluid analyzer. This is the MDT tool and the modules as a modular dynamic tester is a very great important in this case. The basic tool module contains a backer, probe, and telescoping backup pistons, and also have a pressure gauges and temperature gauges and fluid testing or downhole fluid testing chambers, and also have to detect and have to resistivity and temperature sensors to evaluate the fluid type in the flow line. This graph or this chart define the process or the steps for analysis of MDT or modular dynamic tester. The tool position at the desired depth and the formation pressure is obtained by withdrawing a small amount of the fluid from the formation to generate a short transient test. The pressure response is recorded throughout the transient test to determine the formation pressure, which is the stable pressure reached after the shuttle. This is an example for one test regarding the time and the recorded pressure. Starting from the hydrostatic pressure and the drawdown process, and the let the pressure to be built up to a certain value, and this certain value after sometimes will be a constant value. This is an indication for formation pressure, and after that you reach to another value of hydrostatic pressure. So the fluid distribution from a pressure versus depth plot will give you a great information about the gas oil contact, free water level or oil water contact, and to have a water gradient and oil gradient value, and also the gas gradient value. This is a very important chart to draw what about the relationship between depth and the pressure. And also, this is a very good plot in pressure testing, like static pressure gradient or formation pressure gradient, and will be beneficial to know what about the fluid gradients, and what about the depths, and what about the fluid contacts in your reservoir. So the normal pressure distribution from surface throughout a reservoir structure, as you have to locate the pressure gradient for water, and also for gas, and sometimes for oil, or both in gas system. And you have to detect what about the free water level or oil water contact and the gas oil contact. This is will define you what about the perforation interval, and what about the net base thickness, and what about the good interval for production in the completion operation. And sometimes the MDT or the formation testers utilized to evaluate a multi-well, as sometimes you have to analyze some reservoir data, a certain or a constant reservoir, but with a multiple or multi wells is needed, and you will focus in your drilled wells and compare between the drilled well or the control point or the focused well and the other wells in the same reservoir, and to consider what about the formation gradient, and what about the fluid contacts, and what about the new points for pressure. Sometimes you have a supercharged points for abnormal pressure value, and sometimes you have to deal with point, but this point is a poor data with poor data, and you will consider the other or the offset well or the nearest well in this type. So the multi-well evaluation is very important. Even you have some geological effects like faults, like juxtaposing, like deepening angle will be different. And also one of the great function of the modular dynamic tester or the formation tester is the fluid sample collection. And actually we have three types of fluid samples or three methods for fluid samples collection, starting from the wireline test and also in drill stem test, and also in the production test itself. These three methods of fluid samples collection is the own methods to be considered in fluid samples and to be considered in fluid analysis if you need to have a great information and the great data about the fluid analysis. The technology of the modular dynamic tester also reached to be recorded, but in the cased hole. So in cased hole, we have a very great tool or recent tool is called cased hole dynamic tester. The cased hole dynamic tester is a standard tester probe or Barker assembly of the repeat formation tester tool is replaced by a two-shot gun. This two-shot gun that offers low pressure test and two samples on each trip into the well. Sometimes the cased hole dynamic testers designed to drill. This is the steps to design to drill through casing using this puncture tool or the penetrating tool, and also through cement, and to penetrate the injector into the formation. This is operation performed to measure the reservoir pressure, take fluid samples, and to measure what about the downhole fluid properties. And after you finish the measurement or the analysis of the formation, you have to plug the hole with 10,000 psi bi-directional seal. This is like a batch to be potted in the penetrated area or the penetrated casing area or penetrated cement area. But the question is, why behind the casing we need the CHDT or cased hole dynamic tester? We need the CHDT and behind casing for bypassed hydrocarbon. This is an increasing effort to revisit mature fields and reservoirs looking for bypassed bay zone, and the cased hole dynamic tester can be effectively used to evaluate the economic potential of these zones. And the second reason is the multi-layer reservoir pressure monitoring. In a development project concerned with depletion monitoring or injection optimization, current pressure levels can be quickly determined. This allows timely adjustment of strategies to optimize reservoir management. The third reason and the last reason is the new wells with difficult conditions. Sometimes due to adverse hole conditions or critical hole conditions, open hole formation tester may not be possible. And the CHDT or cased hole dynamic tester is a natural choice to evaluate reservoir fluid type and pressure behind the casing, and optional risk and associated costs are minimized in this case, as you deal with a critical hole condition and also you deal with a critical formation testing evaluation operation. This is the tool specifications regarding the casing sizes and the number of holes drilled and plugged in single run, in one run, and what about the overbalance and underbalance operation, and what about the pre-test volume, and what about the downhole temperature and downhole fluid properties. This chart will give you the example for pressure interpretation using the cased hole dynamic tester, starting from the Baker seal test, as it's used a Baker to seal around the area of reservoir, and the second step to drill the casing area, the third step to drill cement, the fourth step to drill the formation itself, and the second step to pre-test and plugging for pressure calculation or pressure determination, and the last one to plug the seal test and the release from the interval. The CHDT interpretation methodology, this will be based on the extension of the MDT pre-test interpretation and uses an equivalent probe radius. This is the equation for the equivalent probe radius regarding the approach between the area of flow in MDT or modular dynamic tester and differentiate between it with the CHDT or cased hole dynamic tester. Thank you for your kind attention. And in the last day, we will talking about the cased hole logging. Now we will consider